Hello sir, this is Kenishit. I am from ECEB section. My roll number is 21951A04C4. Today's my topic is nodal analysis. What is meant by nodal analysis? Nodal analysis is used for solving any electrical network, and it is defined as the mathematical method for calculating the voltage distribution between the circuit nodes. This method is also known as node voltage method, since the node voltages are with respect to the ground. Features of nodal analysis. Nodal analysis is an application of Kirchhoff's current law. When there are n nodes in a given electrical circuit, there will be n1 simultaneous equations to be solved. To obtain all the node voltage, n1 should be solved. The number of non-reference nodes and the number of nodal equation obtained are equal. Procedure of nodal analysis. Step 1. To identify the principal nodes and select one of them as a reference node. This reference node will be treated as the ground. Step 2. All the node voltages with respect to the ground from all the principal nodes should be labeled except the reference node. Step 3. The nodal equation at all the principal nodes except the reference node should have a nodal equation. The nodal equation is obtained from Kirchhoff's current law and then from Ohm's law. Step 4. To obtain the node voltages, the nodal equations can be determined by the following. Step 3. Hence, for a given electrical circuit, the current flowing through any element and the voltage across any element can be determined using the node voltages. What is nodal analysis formula? The formula of a nodal analysis: the network is defined as I is equals to Y into V, where I are the driving current source and V are the nodal voltages to be found, and Y is the admittance matrix of the network, which operates V to give I. Why do we use nodal analysis? We use nodal analysis on a circuit to obtain multiple KCL equations, which are used to solve for voltage and current. The number of KCL equations required in one less than the number of nodes that a circuit has. The number of KCL equations required in one less than the number of nodes circuit has. The extra node may be referred to a page 4 reference node. The page 4 reference node may be referred as the extra circuit the number of KCL equations required. And again, we know that what is the node in a current circuit. By seeing this image, in electrical engineering, a node is any region on a circuit between two circuit elements. In circuit diagrams, connections are idle wires with zero resistance, so a node consists of entire sections of wire between elements, not just a single point. In a node, a circuit between two circuit regions, the connections are idle wires. So the node consists of entire section of a wire between elements, not just a single point. What is KVL means? We know that KVL means is meant by Kirchhoff's voltage law. It states that if any closed loop network, the total voltage around the loop is equal to the sum of all the voltage drops within the same loop, which is also equal to the zero. The total voltage around the loop is equal to the sum of. So the Kirchhoff voltage law must be equal to 0, which also equal to 0. In other words, the algebraic sum of all voltages within the loop must be equal to 0. And what is the Kirchhoff law's formula? The Kirchhoff's current law, KCL, states that the sum of the all currents leaving a node in any electrical network is equal to 0, which is based on a principle of conservation of electric charge. The law is also referred to as a Kirchhoff's first law in formula form. This is given as n integration of I by 1 by I equals to 0. It is also known as KCL's formula. This states that the sum of all current leaving a node in any electrical network is always equals to 0. It is based on the principle of conservation of electrical charge. The law is also referred to as Kirchhoff's law's first law. Where do we use KCL and KVL? We know that KCL means Kirchhoff's current law and the KVL means Kirchhoff's voltage law, which we can use an easy set of equations. If you are doing a resistor network, count if there are more loops or more nodes, KVL if there are more loops, KCL if there are more nodes. We use, when the circuit has more loops, we use that KVL, means Kirchhoff's voltage law. If the circuit has more nodes, we use that KCL, and we know also known as Kirchhoff's current law. In more advanced circuits like transistors, there is normally a very specific mode that lends itself to your problem space, which gives an easy equation. Nodal analysis problems. Example 1. Using a nodal method, find the current through a resistor R2, where by seeing the circuit diagram, even where the current flows 50 volts and resistor 1 is 20 ohms and resistor 2 is 100 ohms, resistor 3 is 120 ohms and resistor 4 is 30 ohms. E2 is equals to 20 volts. In this diagram, we need to find the current through the resistor 2. Then solution. Let us redraw the circuit with naming the nodes and branch currents shown. We take that the corner points A, B, C, D, E, and E1 is equals to 50, R1, R2, R3, and the current I1 and I2 are the current passing through resistors I2, and the current I3 is passing to the R3. At node B, electrically nodes B and C are same. Assuming the probable polarity of the voltage V at node C or B, we thus get 1 plus I plus is equals to plus I1 plus I2 plus I3 plus is equals to plus 20 ohms minus V by resistor 4 is equals to V minus 50 by resistor 1 plus V by R2 plus V by R3, or V minus 20 by 30 plus V minus 50 by 20 plus V by 100 plus V by 120 is equals to 0. And then when we calculating the answer, we get that V is equals to 31.18 volts, where I2 is equals to V by R2. That means we can see that V is equals to 31.18 by R2 is 100 ohms, when A is equals to Armstrongs. Is dividing, when we continue the calculation, we get the answer 0.3118 Armstrongs. In that case, we can use the nodal theory. Second one, Using nodal method, find the current through the resistors in the circuit configuration of figure. At top of the 6 Armstrong's current is flowing to the left, and the 5 ohms R2 is 2 ohms, R3 is 4 ohms, and R4 is 3 ohms, and the battery is 5 volts, and the current passing upward is A and 2V. Naming the respective nodes of the circuit as 1 and 2, assuming the voltage to be V1 positive and V2 positive respectively at these nodes. Nodal equations at nodes 1 and 2 are follows. For node 1, V1 is equal V1 minus 5 by 3 plus V1 by V2 by 2 plus V1 minus V2 by 5 is equal to 6, or V1 into 1 by 3 plus 1 by 2 plus 1 by 5 minus V2 by 2 minus V2 by 5 minus 5 by 3 minus 6 is equal to 0. 31 by 30 V1 minus V2 by 20 minus 121 by 15 is equal to 0. V2 minus V1 by 2 plus V2 minus 2 by 4 is equals to 4. By calculating this, V2 is equals to 1 by 2 plus 1 by 4 minus 1 by V1 by 2 minus 1 by 2 is equals to 4. Or we can write this by 3 by 4 V2 minus V1 by 2 minus 9 by 2 is equals to 0. Solving A and B, V1 is equals to 115.76 V, while V2 is equals to 16.51 V. Current through 3 ohms resistor, V1 minus 5 by 3 is equals to 15.76 minus 5 by 3 is leaping us to 3.6 Armstrongs. Current through 2 resistor, V1 minus V2 by 2 is equals to 15.76 minus 16.51 by 2 is equals to minus 0.375 Armstrongs. Current through 5 resistor, V1 minus 2 by 5 is equals to 15.76 minus 2 by 5 is equals to 2 by 76 Armstrongs. Current through 4 resistors is equals to V2 minus 2 by 4 is equals to, when we know that V2 is equals to 16.51, and substitute in equation 3, 16.51 minus 2 by 4 is equals to 3.63 Armstrongs. And we know that for nodal analysis formula, the network is defined as I is equals to V by into Y, where 1 are the driving current sources, V are the nodal voltages to be found, and Y is the admittance matrix of the network which operates V to get I. Why do we use nodal analysis? We use nodal analysis on a circuits to obtain the multiple KCL equations which are used to solve for voltage and current in a circuit. The number of KCL equations required in one less than the number of nodes that a circuit has. The extra node may refer to a page for reference node. What is a node in a circuit? In electrical engineering, a node is any region on a circuit between two circuit elements. In circuit diagrams, connections are idle wires with zero resistance. So node consists of the entire section of wire between the elements, that so not just a single point. So thank you, sir.